We can look at an energy level diagram and easily see what the highest occupied orbital is. But as usual, the periodic table can help us out as well. On the periodic table, the elements boron through neon are elements 5 through 10, and have 5 through 10 electrons respectively. We saw previously, by looking at the orbital energy level diagrams, that those 6 elements all have their highest occupied orbitals in the 2p sublevel. We should notice that simply by seeing where an element lies on the periodic table will tell us what the highest occupied orbital is. The periodic table naturally breaks itself up into blocks. The first 2 groups belong to what is called the s block. All of them have an s orbital as their highest occupied orbital. The 6 groups on the right, groups 3a to 8a, or 13 to 18, are in the p block, with their highest occupied orbital being a p orbital. Note that helium is an exception. The transition metals belong to the d block, while the lanthanides and actinides belong to the f block. Their highest occupied orbitals are d and f respectively. Remember that when we say an element is in the d block, it is a d sublevel that is in the process of being filled. Within the s block, we can identify the highest occupied orbital by the period. Elements in the second period are in 2s, elements in the 5th period are 5s, and so on. Same within the p block. We've seen that the elements in the second period are 2p, elements in the 4th period are 4p, and so on. The top row in the d block has 3d as their highest occupied orbital. If you're wondering why it doesn't start at 1d or 2d, recall from our discussion of quantum numbers that d orbitals are not present until you get to the n equal 3 level. 3d orbitals are the lowest energy d orbitals. The top row of the f block has 4f as their highest occupied orbital. As with the s and p blocks, you only need to count down from the top in the d and f blocks to identify the highest occupied orbital.